All right, let's pull back the curtain on one of the most common, but maybe most underappreciated magic tricks in our digital lives. That little button that saves us all, the undo button. We're going to dive into how it really works. I mean, really think about it for a second. You type something, you delete a word, you change a color, and your computer just remembers. It remembers every single step in perfect reverse order. How does it do that? Well, it's not magic, but it is a brilliant and surprisingly simple idea from the world of computer science.
The secret sauce is this one simple rule: last in, first out, or LIFO for short. The idea is exactly what it sounds like. The very last thing you did is the very first thing that gets undone. It's the key to how we can backtrack through our mistakes one step at a time.
So this really elegant last in, first out system, it has a name. It's called a stack. This is one of the most fundamental data structures in all of computing, and it's the quiet engine running behind so many features we use every single day. You know, the absolute best way to picture a stack is with this classic analogy. Imagine you're at a diner, right? You've got a stack of clean plates. Where do you put the next clean plate? Right on top. And when a server needs a plate, where do they grab it from? The top. You can't just yank one out from the middle. The whole thing would crash down. That right there is a stack in a nutshell. Okay, so if we can't grab from the middle, how do we work with this stack of data? Well, in programming, it all comes down to three basic moves. First up, we have push. This is just the fancy term for adding a new item, our new plate, to the top of the stack. So let's say you type a sentence in a document. That action gets pushed onto the undo stack. It's now the newest thing on top. And what goes up must come down, right? So next, we have pop. This is when you remove that top item. When you hit that glorious undo button, what the program is really doing is popping your last action off the stack, which reverses it. The plate is gone from the top. And finally, there's peek. Sometimes a program just needs to know what the last thing you did was, but without actually undoing it. Peek lets you, well, peek at the top item, glance at that top plate without actually taking it off the stack. It's just a quick look. So we get the rules: push, pop, and peek. But how do programmers actually build one of these things in the code? It turns out, while the concept is super simple, there are a couple of common ways to construct a stack, and each one has its own pros and cons. You can kind of think of the two main approaches like this. One way is like a flexible chain, where you can just keep adding new links forever if you want. The other way is more like a fixed-size box, where you have a set number of slots. They both get the job done. They're just better for different scenarios. And here's what those blueprints look like. Over on the left, that's our flexible chain. It's called a linked list. See how each block just points to the next one? It's super dynamic. And on the right, that's our fixed-size box, an array. All the data lives together in one solid block of memory. So, which one do you pick? Well, this table kind of breaks it down. The flexible chain, the linked list, is awesome when you have no idea how many undo steps you'll need to save. The box, the array, is usually faster if you know the maximum number of items you'll ever need. It's all about trading a little flexibility for a little performance. Okay, so we've covered the what and the how, but now we get to the really cool part, the why. Why does this simple little data structure matter so much? Because, and I promise you this, once you know what to look for, you will start seeing stacks absolutely everywhere. And here we are full circle. Every single time you type or draw or make any change in an app, that action gets pushed onto a stack. When you hit Control-V, the application simply pops that last action off the stack to reverse it. It is that simple and that incredibly powerful.
How about your web browser's back button? Yep, that's a stack too. Every time you click on a link, the page you just left gets pushed onto a history stack. When you hit back, what do you think happens? It just pops the last page off the stack and takes you right there. And the forward button? You guessed it, that's probably another stack too.
Now, this one is a little deeper, a little more under the hood, but it's fundamental to how pretty much all software works. When a program is running, it uses something called a call stack. Every time a piece of code needs to run another piece of code, it gets pushed onto the stack. When that piece is finished, it gets popped off, and the program knows exactly where to return to. It's how your computer juggles thousands of tasks without getting lost. And honestly, the list just goes on and on. Stacks help calculators figure out complex math problems. They power algorithms that can solve mazes. If you hit a dead end, you just pop your last few moves off the stack and try a different path. It's a true workhorse of computer science. So really, the big takeaway here is simple, but it's pretty profound. That one little rule, last in, first out, is the engine behind some of the most helpful and powerful features we rely on every single day. It's just a perfect example of how a simple, elegant idea can have a massive, massive impact. So now that you're in on the secret, I'll leave you with a question. The next time you're using your phone or your computer, look around. Where else do you see this last in, first out behavior? What other features might just be a simple stack working its magic behind the scenes? Thanks for joining me.